Okay, let's do the test corrections. For homework D. All right, the first one we have is one that'll get you really ready for 6th grade. This is an order of operations problem. Remember, an operation is adding, subtracting, multiplying, and dividing. And this problem actually has more than one of those operations, so you need to do them in a certain order. So we have PEMDAS, please excuse my dear Aunt Sally, or parentheses, exponents, multiply and divide, add and subtract. Okay, so we're going to do those in a certain order. So what's the first thing? We have parentheses. So remember, we make a V. We're going to change 4 take away 2 into one problem. 4 take away 2 is 2. And then we pull everything down. So we pull down the 4, the times, the plus, and the 6. This is like a brand new problem now. So with this new problem, you have to ask yourself, what wins, multiplying or adding? Well, according to the order of operations, multiplying beats adding and subtracting. So we multiply, we get 4 times 2 is 8. Pull everything down, we get plus 6. Do one more V to finish it up to get your answer of 14. If I were to give myself a little bit more space, this would make a triangle, and that's what your middle school teachers are going to want to see. All right, next problem we have is long division. Remember the saying, does McDonald's sell burgers Sundays? What? So the first thing we're going to ask ourselves is, what times 7 equals 3? How many 7s are in 3? 0. So we multiply. 0 times 7 is 0. Subtract and bring down. Some kids skip right to how many 7s are in 33. That's okay. There would be 4. 4 times 7 is 28. Even though 7 times 5 would get you 35 and be closer to the real answer, remember the Price is Right rule. You got to get as close as you can without going over. What is 33 minus 28? It is not 15. You need to borrow. Cross out the 3, make it a 2. Make the 3 into a 13. 13 minus 8 is 5. 2 take away 2 is 0. What do you do after you subtract? You bring down. So let's bring down our 6 with another long arrow. And you ask yourself, how many 7s are in 56? 8, which is a basic fact. 8 times 7 is 56. Subtract, you get remainder 0. Your answer is 48. Next problem. How do you do this kind of problem? When you add and subtract decimals, you do what? That's right, line up the decimals. So let's take 3.14, or 3 and 14 hundredths. And remember what Mr. Manderfeld taught you during the year is what I do right away is put the decimal first. You see how they're lined up right there? Then you can write the 2.9 or the 2 and 9 tenths. Let's add a 0 right here. And subtract. 4 take away 0 is 4. 1 take away 9, you can't do it. Let's borrow, make that a 2. This becomes an 11. 11 minus 9, or 9 is 2. And 2 take away 2. So your answer is 0 and 24 hundredths, or 24 hundredths. Okay, adding fractions with unlike denominators, how do you do that? That's right, we stack it. So let's do 4 eighths plus 2 thirds. Fraction bars far away, common denominator is 24, that's where they'll meet. Your 4 x's, how many 3's are in 24? 8, which gets you 16. How many 8's are in 24? 3, which gets you 12. And then what does Mr. Manderfeld always freak out about? Writing it sideways. So let's do 12 24ths plus 16 24ths equals 28 24ths. If you put that, that is a fine and correct answer. But this is a fraction greater than 1. So you ask yourself, how many 24s can go into 28? One group of 24, which would leave you with 4 remainder, 24. And kids really want to be advanced, you could reduce that to 1/6. So what is your answer? You should be looking if you got 1 and 4 24ths is the correct answer, or 1 and 1/6. Excuse me. Okay, last problem. How do you do this kind of problem? How do you multiply a mixed number by a whole number? That's right, area model. So let's quickly draw our area model, split it into 2 boxes. We're going to take our 2-digit number and split it into 4 and 1/3, and then put our 5 on the side. Okay, what meets in the first box? I'd like you to write it in there. Well, 4 times 5 meets there. Why? 5's coming over, 4's coming down. 4 times 5 is 20. What meets in the second box? 5 times 1/3. How do you do that problem? It's repeated adding, or the Gordon loop. So we get 5/3, but just like the problem previous, this is a fraction greater than 1. So how many 3's go into 5? 1, which will give you 3, but you're trying to get to 5 means there'd be 2 left over. Denominator always stays the same, and then we add these two. So you get 21 and 2/3. If you guys are remembering how to do this, that is awesome. If there's one you don't know how to do or you want any extra help, just email me and we can even do a private Zoom. If you're kind of feeling like you are having trouble with math and need something, just let me know. All right, don't forget to put your answers today on your math sheet for your answers for letter E, for your homework E. There'll be a spot to put your score for today. All right, 5th graders.